Alright, so in this lesson we're going to go over some formulas for finding area with excitement, because there's an exclamation point. That's right. Alright, so let's start with something nice and easy. Let's talk rectangles and squares. Alright? Rectangles and squares. So let's say I've got, we'll go with a square first. So let's call that a square. Okay, well, what do we know about squares? You know that their sides are all congruent. Alright? So I've got, oops, there we go. These guys are all congruent. I'm going to have some congruent tick marks there. Alrighty. Now, we also have all right angles. And we'll talk more about the characteristics of a square at another time, but the area formula for a square, you'll probably want to jot this bad boy down. Area equals, if we're going to call this the base and this the height, it'll be base times height. If you want to call this a side, and we know that this is also a side because a square has all congruent sides, some people will write this as area equals side squared. Excellent. So let's talk about a rectangle here, shall we? So if I have a rectangle, it's actually same formula as a square. If you are thinking in the context of base and height, the area is going to equal the base times the height. Oh, well, I'm going to just give it some arbitrary measurements now. I'm going to say that this guy here is 7 and this one is 3. And let's go with inches. Okay, that's what those quotations there mean. Those are inches. Right? One of them is a foot, 2 is an inch. Okay, so I'm going to have area equals 7 times 3, which equals 21 inches squared. Area is measured in square units. Okay, that's something you're going to see that comes up all the time. You're going to get used to it. But there we go. Same idea would work for a square. Awesome. So let's talk triangles here. Okay, here we go. Let's say I have this nice, wonderful right triangle. Okay, it's a right angle. Well, I'll tell you what. If this was my base and this is my height, area is going to equal, well, let's see here. Think about the rectangle. Base times height. That for sure looks like half a rectangle there. Base times height divided by 2. Boom. Or you can think about it as area equals 1/2 base times height. 1/2 times base times height. Same deal. Some people write it one way, some people write it the other way. Both work. Let's say we have a triangle that's not drawn in such a favorable way. I'm going to go, whee. Okay. No right angles here, dog. Oh my goodness. What are we going to do? Well, I'll tell you what. The main thing we want to remember here is that the base and the height are perpendicular to each other. That just happens with rectangles and squares, but not always with triangles and some of the other shapes we're going to be dealing with here, the other polygons we're going to be dealing with. So what we want is that height to come down. That's going to be our height, which is drawn perpendicular to the base. Okay, so let's say the base of my triangle is equal to, how about 12 centimeters. Woo. And let's say that my height is equal to 3 centimeters. Well, my area, using either one of these formulas, either 1/2 base times height or base times height over 2, I'll do the first one. 12 times 3 over 2. Now in my head, like Jason Derulo, if you remember that song, 12 times 3 is 36, divided by 2 is 18 centimeters squared. There we go. We just found the area of that triangle. Even in the difficult situation where we don't have that right angle given to us, boom, we got that right there, right? Obviously, we're given the height. That's awesome. And sometimes we're given that nice right triangle. It's really easy to find if you're given the right information. Alright, it's time to work out a different part of our mass muscles. How about the traps? I'm hilarious. Okay. Let's talk trapezoids. Sometimes you'll see a trapezoid like so, and it'll be what's called an isosceles trapezoid, where those two legs are congruent. These bases are parallel. That's what those arrows mean, ladies and gentlemen. That's how we notate it. A lot of times in construction plans, we're going to see parallel lines. We're going to assume the parallel lines, and that's just fine. But in the math world, we notate it. If it's not notated, we cannot assume. So that is something that's a little bit weird about this class, where we're dealing construction and we're dealing math. But we will have to figure that out and set those differences aside. Deal with it. Another way we might see one is a trapezoid that might look like... Actually, you know what I'm going to do? I'm not going to make it perfectly right. I'm going to go with something like... Ooh, it's all jacked up. Those guys are parallel still. Sorry if I didn't hit it right on the line. But those two legs are different. Well, guess what? Same formula. If I drop down an altitude, or if I drop down this height, altitude and height mean the same thing, folks. Perpendicular to both bases, right? Perpendicular to both bases. Boom. That height has to be perpendicular to both bases. So our area formula for a trapezoid, we've got two bases we're dealing with. So what we're going to do is we're going to average those bases. We're going to multiply it by the height. 1/2 times the base 1 plus base 2 times our height. That's one way of seeing that formula. Another way, base 1 plus base 2 times our height all over 2. What we're doing here, guys, is we are taking our first base and our second base, adding them together and dividing by 2. We're taking the average of those bases and we're multiplying by the height, just like we would do if it were a rectangle, if it were a square. Let's pop some numbers in here. That often helps us to understand things. Let's say my height is 5. Let's say this base is 8 and this upper base is 3. And we'll go with meters. Okay. Let's use my formula. Area equals base 1. So let's go with the first one. 1/2 times base 1 plus base 2 times my height. Okay. Well, if my base 1 and base 2 add up to 11, half of that is, what, 5.5? If we multiply 5.5 by 5, we're going to get 27.5 meters squared. Woo! Good stuff right there. And you could also plug that in your calculator. If I were to go, boom, boom, times 3 plus 8 in parentheses times 5, I'm clicking it in right now, I still get 27.5 meters squared. Excellent stuff. And that's going to work out for any trapezoid. Base 1 plus base 2 over 2, you're going to multiply that by the height. Okay? You're averaging the bases, you're multiplying by the height. Area of a square, base times height. Area of a rectangle, base times height. Area of a trapezoid, average your bases times your height. See that wonderful similarity there? Let's say we got ourselves a nice parallelogram. Ooh, that's good stuff right there. Got ourselves a parallelogram where we got opposite sides parallel. There's all sorts of other information. Ooh, I should probably put 2 arrows here because they're 2 different sets of sides. Obviously, the ones that intersect are not parallel. That would go against the whole definition of parallel. Okay. So let's see here. If I want to find the area of this thing, it kind of looks like a rectangle to me. Right? It kind of looks like a rectangle, but that rectangle's all been turned. You see? Got it all slanted and stuff. Well, what if I were to take this chunk of triangle and were to pop that chunk of triangle over here? Ooh, ooh. So you're telling me that maybe my formula for a rectangle, formula for a square, almost like the trapezoid, where we got our base times our height. There's my height. Here's my base. Multiply them together and we're good? Heck yeah, I am. Base times height. But remember, the base and the height have to be perpendicular. Super important. So let's say we throw some numbers. Let's say my base is 8 inches. And say my height is 6 inches. Base times height. 48 inches squared. America. So let's say we got ourselves a circle now. Big old circle. Circle's got a center, right? And I believe that thing's got a radius. I like it. Radius. Well, if I'm trying to find the area of a circle, area equals, and we should remember this, pi r squared. And I'm going to throw another one at you because it's super important. Circumference is 2 pi r, or some even use pi times diameter, which is just double the radius. Same formula, just different information. Well, let's say my radius is 10 inches. About 10, sure, inches. We can do inches again. Okay. It's got a 10-inch radius. Well, my area is going to equal pi times 10 squared. I always like to put what I'm squaring in parentheses. That's 100 pi. Nice. Or approximately, well, pi times 100, 0.159, so 16. There we go. And that would be inches squared. Perfect. There's my area. And if I wanted to do circumference, I could. What would it be there? If we have circumference, we'd be in with 2 pi times 10, so 20 pi. And if we wanted to multiply that out in a calculator, we could. We can use that pi button, but there we go. No big deal, just plug and check. So now we're going to deal with some regular polygons. Okay. Now, a regular polygon base just means that you have all sides, all angles congruent. So this pentagon on the left-hand side here, all the sides, all the angles are congruent. Same with the hexagon. All sides, all angles are congruent. I know I didn't draw it perfectly, but let's go with that. Okay. So what you have is actually a center of that polygon, and then this line here is called the apothem, notated with an A. All right, and the same goes with this hexagon. And that apothem is indeed perpendicular to that side. So that's an A right there. That's the apothem. Another part you're going to see is called, and I'm going to draw this in red, this is the radius. Radius, R. The reason why we call that a radius is because a circle can actually be drawn all the way around this and hit every single one of these points. It can be what's called inscribed in the circle if it's drawn properly, if it's a regular polygon. Okay. So our formula is going to be the area equals 1/2 times my apothem times my perimeter. My perimeter, I'm just going to add up all the sides. Alright? So let's just give some, once again, arbitrary values to what we got going on here. Let's say my apothem for this one is going to equal, how about 3? And let's say my side is 5. Nice and easy numbers. I'm not even going to go with units right now. So I've got area equals 1/2 times my apothem of 3 times my perimeter. Well, if I've got 5 sides at 5 apiece, that's 25. Alright, so let's see here. We've got 1/2 times 75. So let's see here. Half of 70 is 35 plus 2.5, so 37.5 would be my area. units squared, since we're talking about area. Okay, not bad. I wonder if there's a different way of thinking about it. Well, stay with me here for a sec. This right here sure as heck looks like part of a triangle. Well, it is a triangle, and then if you extend it, it's another triangle. And how many of these triangles that I'm outlining right now would we have in a pentagon? Ooh, we'd have 5. Boom, there's one. There's another. There's another. And there's another. Oh, yeah. Okay. What if I just found the area of one triangle? Okay. So let's say if I want, let's say I just want to find the area of this one triangle. Oop. That guy right there. Outlined absolutely terribly. Okay. So let's say I want to find the area of that one triangle. Well, I do. Area is going to equal 1/2 times my base, which is 5, because that's the side length, times my height, which is my apothem. So that's going to equal, well, half of 15 is 7.5. And how many of those triangles did we have? Well, 7.5 times 5, that's going to give me 37.5. Same thing, different way of getting it. How cool is that? So if you come up to one of these and you're like, dude, I can't remember that 1/2 apothem times perimeter formula, here you go. Split it into triangles. Works just the same. Okay? It's basically like splitting up into all your bases at once versus just one base at a time and multiplying by how many triangles you have. We'll talk about that one a little bit more in class. Hope you guys enjoyed all these awesome formulas. Time to apply them. Time to do a little application. I know you're pumped for that.